Okay. So, should we start? So I have this timer. I am 11:20, 40 minutes on this. So, okay. My name is Cristian. My presentation is all about accessible computing and in accessibility on accessible computing. And pretty much to give some intro, who am I? I'm developer. I was iOS developer. I'm not anymore. I'm Vision OS developer now. I've been working with Apple platforms for. I just look it up on Siri Intelligence now. It's like I started with Xcode 4, and Xcode 4 was pretty much released on March of 2011. So yeah, so pretty much I'm in this community for 13 years. And my background is on art, liberal art. This is what I studied in university. Then I did some computer science. But I always taken the humanistic side of technology. I'm always been interested in how we solve human problems on technology. And that means like during all these years, I had a ton of meetings where I have to play the role of advocate of accessibility when constructing products. And one of the repeating patterns I found in these meetings is that you really fast get to this concept of like, yeah, we are doing this for the average user. Everything else is an edge case, right? And this is where I use this phrase, so I give it to you so you can use it if you want, right? Which is pretty much is like an edge case defines what is the limits of your interest, what you're interested on. Anything outside your edge case, if you don't care or if the app is not addressing it, it means like it's something like it's not interesting for you or your product. So one of the reasons I speak about accessibility is something called the curb cut effect, which is a ramp on pretty much on the streets, pretty common here in Seoul, as far as I can see. And this came as pretty much a solution, an architectural solution for disability, right? Like being able to use it with a wheelchair. But the thing is, like, literally, really fast. This came something like many people could use with or without disability, and this was like a chance, a side effect of like constructing for accessibility can bring benefits, for more people. With different range of necessities, right? Like if you are skateboarding or the strolls, like if you are a mother, etc. So I do like to use the curb cut effect as something also to convince people. It's like if you do this, also you are benefiting even your users. You are not, probably you don't know that you are already neglecting your users. So you should work on that. For doing this work, again, we have to do this intro for pretty much also helping to address and how we talk about the topic, something like it has been difficult for me. I struggle to get the right words and to be proper and inclusive when I talk. And the first thing I define when we have to do some workshops is the domains. This is the mostly what we understand of like the range or the spectrum of the needs of different users. And one important thing to have, like if you forget all about this presentation, is the only thing you need to remember is like you should always reevaluate your assumptions on everything. And when you talk about the domains, we are talking about the whole spectrum of vision impairments, right? It can be like from you are waking up early, there is not enough light in this room, to like being completely blind, which is also like usually like a lower percentage of users. Being completely blind is like probably less than 10%. So basically, when we talk about vision and issues with vision, we are talking about the whole spectrum of anything that affects your normal perception, your visual perception, right? This is how it's defined on the documentation on Apple. The same for speech. It's not only about like extreme cases of speech. It can be my accent right now. It can be the language barrier. We're using tools, right, for overcoming or trying to overcome these barriers. So anything that impacts your ability of express yourself, right, or connect, right, with your voice, is considered part of the spectrum of the domain of a speech impairment. Again, reevaluate the mobility, right? You have like temporary disabilities, right? You have contextual disabilities. It's not only about the extremes, it's about the whole spectrum. And it's important to keep in mind when you are developing, right? Same with cognitive, and again, same with hearing. And are the domains that you usually get in your knowledge, right? When you approach accessibility on Apple platforms. But also it's important to know that usually disabilities comes in tandems, they come in groups. It's really uncommon that you have like only one type of disability. Usually they come in pairs. So that means like the features are used by the users in combination, right? And the features, we call them assistive features. And we have to understand them, right? Why they are designed like that, how we address them, how we implement for those. And one interesting thing on a specific of the Vision Pro, I'm not going to be as brave as Bibi doing a live demo, right? But, sorry, is Bibi around? So anyway, kudos for that. It's one of the interesting things. I'm not going to do the demo, although I should do it. I don't know. Let me think about it. Depends on the time. One of the interesting things for me when I was working on augmented reality before the release of Vision Pro is that when the Vision Pro was released, the first video of spatial computing accessibility, they said, one of the first things they said, this is the largest list of accessibility features we ever included in the first generation of a product. And to me, this was like okay, this is bold to say at least, right? It's like is this even true, right? It's like it looks like this is from the same presentation and the slides, right? And it was like, yeah, it looks like pretty much like every feature that we know from the iPad OS or iOS are kind of included on Vision OS, but I needed to verify, I needed to be sure about this, right? So I went and counted, and pretty much there are around 170 features. Some of them are level of implementation. You can use them, so it's kind of difficult to count. But this is pretty much the amount of features that Vision OS comes, or at least came on the before Vision OS 2. Now there are some new features. And also this is the domain priority of these features, right? So they're basically addressing vision issues and physical hearing, and then more general. Again, 170 features. We don't know if that's a lot or not, right? This is something meaningful or not. So I went and counted the features for the Meta Quest 3, right? And this is the accessibility features compared to, which is, a magnitude level of difference, right? It's pretty much Vision Pro is literally one of the most accessible head-mounted displays in the market, and it's really, it seems, like it's a device that is pretty much well implemented for accessibility. To be fair, right, I don't like this comparison like Android, iOS, etc. So I have to mention that Meta is doing strides, and Reality Labs have really good people inside, and they're doing work for implementing accessibility. This is the just release equivalent to the HIG of Meta, where they explain how to implement. And this type of partnerships, like with Be My Eyes for the Ray-Ban glasses, is something like to pay attention and to respect on that. So I went and compared to the first generation of the iPhone, right? To be more fair, right? And the thing is, like the first generation of the iPhone didn't have any accessibility feature at all. So it seems like it holds now the claim that Vision Pro is really an accessible device. And in fact, it was not until 2009, right? That's kind of like 15 years ago that any accessibility feature was implemented on iOS. And this was really meaningful. And there is this is the QR for a podcast. Maybe a recording of something called the 36 seconds that changed everything. Right? It's like how the iPhone learned to talk and how meaningful. It was voiceover for the community. It's like suddenly this slate of glass that was completely inaccessible became a tool that now is considered the standard, the golden standard for accessibility. And it's called 36 seconds because Phil Schiller presented in a fashion that it was not recognizable for the Apple of now. That is was like now we have voiceover and accessibility, and we have Nike bands on watch. So it was like really, really short presentation, but it was a huge impact for the disabled community. So I totally recommend to go and hear this thing. Also, it puts on perspective that the assistive technology is at the end of the day software that we create and we iterate, and we have sometimes we have bugs, right? And we have implementations of it. So that means also the idea of creating accessibility comes to the level that we can create assistive technology. So the assistive technology is pretty much the apps that we use for handling these domains and for offering and grouping the features that we mentioned before. The main ones, or at least the big ones, are VoiceOver, which is a screen reader. Pretty much it's implemented in a similar fashion on Vision OS. I go on detail a bit more later. I can barely see. Let me focus this. Voice control is basically you can command to your device, to your voice. You can even use a custom commands. And then you have a switch control, which allows you to connect peripherals and use different types of inputs to control the system itself, right? These are really interesting. And again, this is a voiceover, a bit more in the fashion of how it's in Vision OS. This is how it looks. The settings, right? It's more a bit of context. It's if I'm a user and I need VoiceOver, I'm going to be offered the option to activate VoiceOver even in the onboarding. As soon you have a delay, it's going to be offered. But if not, you can always access on the settings, or you can activate with Siri. Same thing with voice control. This is implemented on Vision OS. You can find it on settings. You can activate with Siri. Switch control, same story, right? This boils down, now that you have the domains and assistive technologies and the software that we use for them, to how we interact with the system. And for that, we need to understand a bit of interaction modes, right? It's how you control what you want to do, how you hint your intent, how you trigger. And you go back to how we control the devices from terminal. In fact, it's now in fashion, right, with ChatGPT and all this, controlling with the text and directly writing what you want. Then we have the breakthrough of the indirect interaction, controlling a kind of a device, external third-party device. And then you have the pointer, which shows where you want to control something, and the click confirms your intent. Then we have a direct interaction, which is pretty much how we are used to control touch screens. It's what I want to touch, I'm going and touch it directly. And some interesting stuff going on with proximity interactions and how we navigate the space and so on. Now, Vision OS is the first device from Apple that comes with both indirect and direct interaction activated by default. And this is meaningful, right? Until now, we have devices that came only indirect, like the Mac, or only direct, like the iPad or iPhone. And this one is different, right? We have the direct gestures, which is pretty much the ability of manipulate objects that you touch. And yes, you can go closer to the object and touch it, right? And this is true for whatever interaction you want to create. And for example, the keyboard, right? You can get close to the keyboard and you can tap the keys to type your input. So this is considered direct type of gestures. Important to understand that the direct gestures are not really precise, right? And they have this of requirement that you need to be close enough to the object that you want to interact with, to be able to control it, right? So that creates a barrier. It's you should be able to move, you should be able to touch it, you should be able to be as close. And on top of that, right, it's not as precise, right, because technology. So every time you consider yourself implementing a direct gesture, think about this, right? It's it's not precise and it has a list of requirements not to be able to be triggered. On the other side, You have the indirect gestures, which is what is considered the default kind of way of using the Vision Pro. And basically, it's like the relation between where you are focusing and how you trigger the standard gestures. By standard, I mean like a pinch, zoom, and all the gestures that you are used to if you use the iPhone with touchscreen, right? Indirect interactions are faster, are more comfortable. You can rest your hand in your lap. You don't need to move so much. You don't have to stretch yourself. And also allows you to control elements that are not only far from you, also like it can be like as big as whatever you want, right? So you can move planets with your eyes and your hands, right? I hope it makes sense, the translation. That's it. Anyway, so indirect interaction is the gaze and pinch that we know, right? It's like you hint where you want to trigger an action by looking at it, and then you pinch, and the cameras are going to really capture in a wide range of your field of view, and that means like pretty much it feels like magical. Like you can rest your hand almost everywhere, and the device is going to know that you are doing this gesture. Another example that came with Vision S2, that maybe it's on the border of indirect and indirect, is this type of control that you can raise your hand, you have control center, you can go to more fine-grained control center, and you can change the volume directly on that. This type of interactions are interesting in the sense of like, because they address different type of needs when inputting and controlling the device. But I don't like to say the tip of the iceberg, but this is only the beginning, right? So the amount of input controls that you have for controlling the device or the system, it's a huge range. And this is important for us as developers because it means, again, that you have to reevaluate your assumption that people is going to use your app or your system in a predefined way with a predefined input. In fact, this is the official documentation. This is not even all of them. This is like most of the input devices that are recognized across the platforms. And on a specific on Vision OS, these are the possibilities that the user can use for controlling and inputting the intent. So it's not about gazing. It can be a Bluetooth device, can be a keyboard, can be like a wider range of input controls, physical controls in some points. And this is growing, right? We have new controls, and probably we're going to see this evolution. And it's really exciting. It's really interesting. There is a lot of innovation here. You should pay attention. I invite you. This is an example of, for example, how the cursor works when you use a trackpad and the eyes to control a web page. In this case, what you are seeing there, this dot that pretty much moves like a agitated, it's the eye tracking. And what it's doing, the trackpad, is pretty much it jumps the cursor, so the window of control where the cursor is where you are looking at. This allows you to really not having to move so much the hand when you are tracking the mouse, to call it in a way, right? So really smart things, really interesting. And when you use the device, you don't even notice it, right? I was using the device for almost a year. It's already a year? I mean, for a long time. And I didn't know about this until I found in documentation. It was, oh, okay, right, this is how it's implemented. I look there, and suddenly your cursor is teleported there. Similar fashion to Apple TV somehow, right? Some examples, so you know how they look and what they do. This is the settings of accessibility. This is an old screenshot from the same session I referred before. Many details. I find this fascinating. I hope I can transmit it. For example, when you reduce motion, even your immersiveness is taking it on account. So here the lake, the waves, the ripples are going to be in a slower pace, so it's really more comfortable for you, right? When you have dual control, when you need assistance for doing the gestures, right? You have like a whole range of tools, and they work really impressive. They're attached to your head, and when you move your head, you have this floating control, and pretty much it's like you can trigger anything from the dual control. For example, like with a keyboard, and you can even change, the altitude of the camera where you are located. So you also address, maybe you don't assume that somebody is at certain height not looking at your perspective, right? It's a great device for cognitive disabilities. The ability of you are so focused when you are in this device. I should not do this example because I didn't rehearse it, but anyway, I'm gonna do it anyway. So I was in an expo in Riyadh, and I had to work in real time. I had to code something for the demo that we were doing in the booth, and I was in front of a screen that it was flashing anime. It was flashing like a really stroboscopic effect. And I was unable to work with it, but I was wearing the Vision Pro because I was coding for it. And I turned it on, the immersiveness, and suddenly I was away. I was completely like a sound, like a noise cancellation for the view, for the mind. And to me, this was like a revelation, right? It's like a guided access and cognitive issues can be really addressed in interesting ways on Vision Pro. There are details, like even the small details, right? Like how you put captions, subtitles, have been studied to like how you control the depth of the subtitle when you have like a 3D video, right? And how you compensate this kind of like a depth conflict, which is the parallax and the depth. This is solved. It comes for free when you implement captions or you add captions on your media. This is an example of pointer control. If you are unable to use your eyes to move the cursor and to hint your intent, you can connect the cursor to, for example, your wrist, and then you can use your hand to tell the system what do you want to interact with. You can also control it with the head, meaning it's going to spawn a ray from the center of your eyes a bit higher, and pretty much you can use your head to, again, hint the system what you want to control. Magnifier. Sadly, it only works for virtual content, but it works, right? So yeah, at some point, privacy concerns, right? It cannot be used with the real pass-through, but yeah, interesting anyways there. How you implement this, right? Developers, pretty much. The entry barrier for implementing accessibility on Vision OS is really low. The same for implementing Swift UI, right? So if you know Swift UI, you know a bit the modifiers of Swift UI, you're pretty much covered for all the apps that are Windows, right? So when you go for 2D Windows, you pretty much follow the Swift UI conventions. But when you want to go more immersive and you want to go for volumetric type of components, or you want to go for immersive, you need to get something called accessibility component, which requires to dig a bit on what is basically ECS and what is the architecture of RealityKit. So RealityKit is the rendering engine that VisionOS uses, and it uses the architecture called ECS, which is the Entity Component System. Probably you heard this a lot of times, but let me be repetitive here. It's an architecture designed for real-time use on video games, so it's pretty much a standard in that world. And what it means is that you have a tree of entities, which are abstract nodes, that require a component for every entity to give them some logic. And then you have systems that allows you to coordinate if you want to, for example, do a flock or do something coordinated between a specific type of entities and with a specific type of components. So what it means for us, so if you are going to do some interaction with a ball, for example, you have like an entity that has a model component for a ball, and then you will add on that entity an extra component called the accessibility component. Accessibility component is not much than the same Swift UI accessibility modifiers, but for the RealityKit world. So pretty much they have the same properties and they work in a similar fashion. And again, you can go and go and go, right? So pretty much what I'm saying is like if you are going to do some RealityKit, you need to add your accessibility component so you can declare this type of properties as you will do on Swift UI. So you say that it's an accessibility element, you express what type of traits so the system knows how to read it to the user or how to express it, how to describe, and so on, right? There is even custom rotors. And as of iOS 17, this is also something you can use across platforms, right? Which becomes really interesting. Before this was like a one-off for Vision OS and a different implementation for iPad OS and iOS, and that's not true anymore, right? You can develop one platform, one experience, more or less, with the difference of ARKit. But from the point of view of Reality Kit, right? It's like pretty much the same options, right? This is an example. I think I went too fast, so maybe it's like so this is an implementation. Can you raise the volume a bit? Yeah, before I enter on this, right? This is an immersive app, simple app, right? Pretty much it's a matching card game that you need to use some assistive technology to be able to solve it, right? This is part of a challenge that was done by Apple in 2000 something, 21, I think, but it was done on 2D. So I ported to Vision OS to show it, right? So pretty much what I'm doing here, my hands is like I'm using the gestures for controlling voiceover. So I'm navigating with one hand and activating and triggering the gestures in the other hand. And have the voiceover reading me the properties and the traits and the descriptions to being able to solve this, right? So what you should pay attention is like all the details that we have to bring over, right, to make sense of this game, right? Yeah. So pretty much is all this can be iterated, right? And you can go as deep as you want. For example, like the motion of the cards can be something like you could control with environment system, right? Environment values and see if the user has activated or not, like disable motion, so you don't have to animate everything. Again, there is hints, right, on all these affordances for like a sound, being able to know when the state of the card, being able to know if you are matching or you are not matching. And yeah, probably you can add some actions for like doing shortcuts for the cards and everything else. I have the code. It's not the QR. I forgot that, but maybe in the QA I will share it. It's on GitHub. Pretty much, if you follow me on GitHub, you are going to find the source code and you can see it. So that's pretty much it. So what is the taking away from this, right? Is that Vision OS is definitely an accessible system, and Vision Pro, it can be a differential, right? Because it allows you to interact with your space in many, many different ways, in fact, more than any other device. And pretty much you are hands-free, you have the option, you have the context awareness. So it's a device that is able to understand your context and is able to understand your intent and the way that you want to act with your environment in much more interesting ways. And this is not even counting in the future with the implementation of AI and other stuff. So I'm really optimistic. It's a really life-changing device for many users. And yeah, usually I show a video, but I'm not gonna do it, but I'm short on time. So thank you very much. And I hope you enjoy this. Yes. Somebody? Do you want to take over? Any question? Should I dance? Okay.